Welcome to AutoSens, the world's leading community for ADAS and autonomous vehicle technology development. We create best-in-class events, training, and information for the purpose of connecting the global community of engineers, scientists, and other automotive industry experts. We are joined today by Bart Plackle, VP of Automotive for imec. And Bart, welcome to AutoSens. Thank you for being here.
Really pleasure to be here, so thanks so much.
Bart, we are going to talk about chiplets today, and I suppose the biggest question just right at the beginning is, one, what are chiplets? And two, why are they relevant for automotive?
Yeah, perfect questions. So let's start with what are chips. So if you look at what I have in my hand, this is typically what you find in everyday's computer. This piece of silicon, it has billions of transistors. And if you look at, you cannot see it, but if you look at the die itself, in that die, you have a GPU, you have CPU, you have memory control. So all big building blocks integrated on a monolithic IC. That's how it's being developed today. Now, here comes the challenge. So as compute requirements are really going to the roof, we first saw this with supercomputers, and now we're also seeing it for consumer. And we're reaching a point with automotive, with cars becoming autonomous. We're reaching the point that we need so much processing power, which means we need so much transistors, we no longer can get them on single die. So a single die, that's defined, the maximum size is defined by the process and lithography. So there's a finite structure that you can build those transistors. So if you have a very complex design, you have to break the architecture into many pieces. And typically you want to do it in logical building blocks like a GPU, CPU, and whatever. There is a second reason why you want to break it up into multiple smaller sizes. And it is as your die size increases, what you will see is that you always have defects. And if such a defect hits your specific processor, that processor will probably no longer work. And the bigger your die sizes come, the chances that your processor is defect rises exponentially. So that's the reason why you want to keep them small. So the yield, so the cost of throwing away dies, plus the transistor density, that makes you want to break up the architecture in multiple pieces. So that's what's happening. And what's interesting is that the transition happened already quite a few years ago outside of automotive, because the supercomputers, if you look at Intel Ponte Vecchio, that's a technology marvel where they have like 40 different dies on an architecture, on a package, and together that brings your functionality. So that's where it really started. Now in the server market, if you look at the AMD EPYC, they already have like 96 cores. Again, they had to break it up into multiple pieces to make it viable. And slowly we're moving into the consumer space. So now Intel with Meteor Lake, or even the Apple 1M Ultra, they're using a chiplet-based architectures for creating a cost-effective product.
Bart, with that groundwork laid there, let's talk about how the automotive market can take advantage of chiplets.
Yeah, so if we look at the autonomous vehicles, so you have the L2, which is ADAS, and then you really go into full autonomous L3, L4, and L5. And if you look at those processing requirements, they truly go into the roof. If you look at the 2025 autonomous vehicle, you're processing 100 gigabits of sensor information. Roughly, you need a few thousand TOPS to process it all. And that's nothing less than a real supercomputer. So what we're actually doing in the autonomous world of the automotive world is bringing a supercomputer into the car. But this is where the challenge starts. It's not just saying, okay, we need more transistors, so we're going to break up the architecture in different pieces. We also have to make sure that we have an architecture that is cost effective. So the cost of autonomous cars, the price points will probably increase, but they're not so flexible that suddenly the price can double. So we have to make sure that it's cost effective. We have to make sure that it's low power, because in the end, most of the vehicles are going to be driven from the battery. So we cannot really compromise the range. and it has to be reliable and safe. And this is where we comfortably can state that you no longer can build such complex architectures for the medium volume market like automotive. Automotive is like in 90 million market. And if you then look at like how much of that fraction is really going into the higher end L2, L3, L4, that's a fraction of the market. And if you really have to develop for such smaller amount of market, you really have to come up with new architecture. And that's really what Chiplets gives you. So it's not just from the economics, it's not just from physically, you have to spread it out, but it also reduces the development cost for such medium volume markets.
We're speaking as part of AutoSens Brussels with Bart Plackle, VP of Automotive for imec. Bart, let's talk about the imec chiplet initiative. What is your role there?
Yeah, so as you could have seen throughout the whole story of chiplets, we are hitting the brick wall. What we're now seeing is that we're not fast enough to do the transition to chiplets. And this is where imec is putting all its strength to try to accelerate this right-hand turn into chiplets. And we do it in two ways. The first one is we're bringing really the who is who from the automotive industry together. We started the initiative in February, and our first official get-together around chiplets was in June. And this was a forum where we brought together tier 2s, tier 1s, OSATs, EDA vendors, all together to really discuss how we can ensure a very solid system-level interoperability of chiplets. So really, how can we turn the vision of shopping around chiplets and integrating into reality? Having all the players throughout the supply chain, I think that's the key to success to make the transition happen. So that's the first thing that we're doing. Second thing that we're doing, that's imec specific. When we're talking about those chiplets, the first two questions we always get is like, are chiplets, the transition to chiplets, is it affordable? And the second question is it reliable? And for those two questions, we are building up a program where we're building an architecture with various interconnects, with various technologies to really prove out to the industry in specific configurations. Yes, in this specific interconnect, you can fulfill all the automotive boundary conditions. And yes, with this type of architecture stacking, you will save so much money by doing the right integration. So those are the two things that we're doing at imec. First, bringing the ecosystem together, because the only way we succeed is we get the whole industry on board, and then addressing the two key challenges like, can it be cost effective and can it be reliable?
Bart, from your vantage point, when do you see chiplets happening in automotive?
The good thing is there's a tons of OEMs today already looking into chiplets. Clearly, that's not enough. But we can also say that there are already OEMs actively building chiplet-based architectures. There are tier 1s who are building a whole portfolio of chiplets for their automotive offerings. So when they hit the market, it really depends on the specific OEMs and when they will hit their car refreshes. But we see an aggressive milestone. We'll have to see if we can hit that towards 2028. And that's really pushing the boundaries of technology. And then as we go along, 2030, 2032, these are the refresh cycles that we typically see chiplets coming to market. And as said, chiplets is for the high-end and premium. So the whole story that we did here for chiplets is really where you need to have so much performance and power that you break out the envelope of what a single die can do. So that's the caveat I need to say when you say, okay, this is when you see chiplets. For the lower end designs, they are still okay to continue the path for monolithic integration.
Speaking today with Bart Plackle, VP of Automotive for imec, and giving us a deep dive into the world of chiplets. Bart, from all of us here at AutoSens, we want to thank you for your time, for being with us, for sharing your expertise and your thought leadership. It'll be interesting to have this discussion, maybe a year from now, just to see what has changed. So we look forward to having you back. In the meantime, safe travels to Brussels, and thank you for being with us.
My pleasure. Thanks so much.
For more in-depth interviews like this, subscribe to our YouTube channel and follow AutoSens on LinkedIn. For more information about our world-class events, visit auto-sense.com. That's auto-sense.com. In Detroit, on behalf of AutoSens, I'm Carl Anthony.